Hello, let's do the Netflix puzzled Starstruck for March 17th. Do the easy then the hard. The easy is called Snakes Out. Let's play. So, the way we play this game is in each row, each column, and each colored region, we need to place exactly one star, and also stars can't touch each other, even diagonally. That's a very important rule. So a star here and a star here would be disallowed. All right, so to start off, we have a couple of these two-cell regions. So a star is going to end up either here or here, meaning the rest of the row can't have another star. Same here. But also, this two-cell region takes out from the two on the top and two on the bottom because they touch both of them, right? Stars can't touch each other, so this star would touch either one. But also, we have this sort of lineup happening, which you can just immediately recognize, especially with two-cell regions, which is that in these two columns, we only get two stars. One's going to be in yellow, one's going to be in gray. So you can't have more stars in these two columns, right? We don't know whether they're like this or whether they're like this, but they're going to use up the two columns. Red now has only one place to put a star. Blue has one place to put a star. Orange has one place to put a star, which resolves our two stars in these two. And then there's probably something easy. Green has two left, so it takes out from those two and this one. And now indigo has one place for a star. Brown has one place. Green has one place. All right. Kind of a lesson on two-cell regions, I suppose. Let's continue. That's on the line of being a plonker. Like, I think you can do that really quickly, but you do have to recognize those formations. But it's just the two-star formation, so I feel like I can include the two-star formation in plonkerism. All right, for St. Patrick's Day, we have four-leaf clover for the hard. Let's play. All right, we got a one-cell region. We just place that. Two left here. We take out from all those. So we have this top row and right column that are completely indigo. So we need to place a star in this row and a star in this column, but we only get one star total, so it has to be where they intersect. All right. Two left in brown takes out from the rest of the column, and these two. Two left in yellow. Is there any more eliminations that... Yes, that eliminates this one. This one touches this one and shares a row with this one. So wherever the yellow is, it takes out of here, which means that this is our last star in brown. I don't think green has any more. Yellow and green line up, though, these two and these two. So that's out, and that gives us the blue. All right. Red is down to these two. Orange is down to these three. Interesting. Is there an obvious deduction here? I'm looking. These two. What's kind of this is a symmetry breaker, which makes me think this is our answer. Just for that reason, so that we don't have two solutions. But why wouldn't the other ones work? Huh. Like, I think this places a star here and here and here. Something like this would put a star here and here. So yeah, that's an issue. I don't know how to describe this well, except pulling out my pen, but I mean, first of all, it's fairly clear that if the stars ended up in this pattern here without being in this one, like, it feels like there's some symmetry here that we'd have to break. But then again, this is like this and this is like that. But anyway, the real point that I want to make is that a star here puts a star here in green, which puts a star here in yellow, and now there's nowhere to put a star in red. And I don't know a better way to put that, but it's not that hard to see. There's not much left in the puzzle. So that's not a star. That leaves these two. So that's out. And that places this one, and this one, and this one, and that one. It is where I said it should be. I don't know. That's a bit of a look ahead, but I'm not sure if there's like a cleaner way to have noticed that. Maybe there was an X-wing or something. I wish I could go back and look. In fact, I will by using an incognito window. I'd like to investigate that further because I didn't really like that last step very much. So let me make sure I'm capturing it. Last thing I need is to describe what I'm doing and then not actually have it captured. Okay. This didn't take very long, so we can make this video a little longer, right? Short videos perform better than long videos generally, just to let you know. So this is for you and for me. All right, so we're just going to quickly get through what we already had here. Out of those. And then these line up. There was definitely something else going on here. Sorry, I'm going quickly, which may not... Oh, yeah, these two saw this one, so that's out. Okay, so we're back to this state. I'm wondering if there's a X-wing. So, like, if we take this column and this column and this row and this row... Thing is, there's only 4 regions left, so I don't know how you would do an X-wing with only 4 regions left. Of course, there's going to be a star in each region. But this doesn't cover all of orange, is the issue. So I think we'd have to take this column to cover all of orange properly. And we'd have to take the... Okay, so let's clear this out. I think we have to take this column. I'm trying to cover the entirety of... Yeah, this... Oh, see, I can't cover the entirety of these 4 regions with only 4 rows, or 2 rows and 2 columns. I always leave one out. So what does that mean? It means I can't do any logic that way. I thought maybe I could. That's interesting. If I take this row, then that's out. And if I take this row, then that's out. Okay, well, that's a bust, isn't it? I can't think of another way to do this. There's definitely a relationship between these. Like, this goes to here. This and this. One of these two must be true, for example. If this is true, then that's true. I don't remember. Oh, this was our solution. So both, it's almost like there's this sort of parity argument almost. Circling these doesn't really help too much. I'm not sure how to represent this, but you'll notice that this line goes this way, this line goes this way, and this line goes this way. So you would expect to have to do this for it to actually work out. There's kind of a parity break here where either of these breaks are kind of cycle. So it's kind of like a cycle parity argument where no matter how we fill these, both of these get cut off. So maybe that's kind of the point, right? So like, there's not really a great way to analyze this other than just to deal with the 2 options for these 3, right? This is one of the options, and then I'll change my color. And this is the other option, right? Either red or blue will be true for sure. And you can see that this cell sees a red and a blue, and this cell sees a red and a blue. So they can't be true. Oops, I didn't mean to undo that one. I meant to undo this one. Right. These are related in that way. And so there is no world where this can be true. There is no world where this can be true. And I think that's the best we're going to do. And that eliminates the blue case, giving us the red case. All right. Anyway, I'm not sure how much better that was, but it's kind of more of a straightforward argument than if I place it here, then things break. It kind of explains why they break. It's because of the way that these have to resolve. And I do think that there's something there with, you know, the line was the wrong direction for orange. So we couldn't put it there. Anyway, how'd you do?